Hello. So I'm going to be walking through how to solve this problem where a spring is compressed. We're looking for the first part is we're looking for the velocity of the block when the spring is at equilibrium. So at this point where the spring is right here. So right now our spring is compressed a distance of 0.2 meters. So we're just going to start the problem now. We're going to start with this equation, E initial equals to E final. So let's look at the final or initial energies we have right now. To start this problem off, we're going to set this as the height for 0. The height is 0. So where the block is currently at, or resting, on the spring, this is going to be 0. So because it's at 0, sorry for being so repetitive, potential energy will also not exist right now. So we're going to have only U spring, or spring potential energy. And then when the block hits here, we're looking for when the block is at equilibrium. When it's here, it actually has kinetic energy as well as potential energy. So basically what this is saying is when the block is here, all of the spring potential energy will be converted into kinetic and potential energy. So let's write this out. 1/2 kx squared is equal to 1/2 mv squared plus mgh. So we just do a plug and chug. We need to find h here. So this will be, I'm going to redraw the triangle here. So that we're looking at the triangle right here. This will be 0.2, 32 degrees. We're looking for h. So this is just basic trigonometry. 0.2 sine theta. This should give us 0.2 sine. Oh my god, my calculator. So this should give us 0.105 or 106 meters. So let's just do plug and chug. We're going to use 10 for gravity. Our block is currently 1.5 kilograms, just FYI. And then plus, we're looking for V squared, or V, we're looking for V here, so we'll leave that empty. The mass is 1.5, 1/2 equals to 0.2 squared. I wrote a little too big, let me move this aside. One half 735 and 0.2 squared. So we're doing essentially 0.04, 735 divided by 2. It's 367.5 times 0.04. This should give us 14.7. And then this should give us 0.75. So we're just going to write that 0.75 v squared plus 15 times 0.01 or 0.106. 0.106. Okay. That should give us 1.59. We're just going to subtract this 1.59. 14.7 minus 1.59 is equal to 13.11 divided by 0.75 is equal to 17.5. Square root that. That will give us 4.18 meters per second as our velocity at equilibrium. So what's the max height the block slides of the ramp. So, because we already know what this is, we're looking for this entire thing. So we're just gonna, right off the bat, just put plus 0.2 here. H plus 0.02. Just write that off to the side. Put that right there. Again, we're going to start with E initial plus E, or equals to E final. We're going to do U spring, so spring potential energy. We know from this equation that that's going to give us 14.7. That's going to be equal to... Okay, so I need to preface something here. Because we're looking at something at the maximum height, so MGH is at the maximum it could be. At this point, all of the kinetic energy has been converted to potential energy, therefore kinetic energy will be 0. So U spring energy will be equal to potential energy only. So this is going to be 1/2, sorry, MGH plus 0.2. We know this is 15, so 14.7 divided by 15 is going to give us 0.98 equals to height plus 0.2. So we know that this height is 0.2. Oh, sorry. This should be D, not height, sorry. We're going to find this first. We're going to find the hypotenuse first and then find H. So because we're looking at D right now and we need to find H, we're going to take this value that we get and then put that into sine 32. Because we're going to be finding the opposite here, which is our H. This is the hypotenuse. We're just using basic trigonometry here. So we're just gonna take this, divide 9.98 divided by sine 32. Sine 32 itself is 0.53. So 0.98 divided by 0.53 is going to give us 1.85 equals to D plus 0.2 minus 0.2. You're going to get 1.65 equals to D, or H, for your final height. Thanks for watching. Come back, please. Or thanks for watching, everyone.